Hi guys, welcome to our channel of Sciences and Mathematics. Today we're going to look at a concept in the structure of benzene, of course, that we have discussed in some of our videos. But today's topic will mainly be pertaining to substitution of benzenes at different substitutional levels. Of course, we have monosubstituted, disubstituted, and polysubstituted benzene. But today we are going to look at general molecules which have undergone a monosubstitution. Of course, this is going to stem from the concept of electrophilic substitution reactions that we have discussed in one of our videos, which I'm going to put a link in the description box below. So for that case, without further ado, thank you and welcome. So as I've mentioned, we are going to look at a category of substituted benzenes, which are known as benzene derivatives. Which of course are substituted benzenes. And as I've said, we are going to look at the class of substituted benzenes. Monosubstituted benzenes. So basically we are going to look at how these substituted benzenes can be referred to, because they have special names, which we are going to find in different areas, of course, of organic synthesis and other subjects which constitutes this kind of molecules. So in this case, it's going to assist us, of course, to try to also name some of the compounds that we may come across, because these special names, whenever they appear, like benzene, of course, I've said it's a special name, and others that we're going to mention. So for that case, I'm just going to have a demonstration of the benzene molecules, and we're going to see how different substitutional levels from the mono, the di, and the polysubstituted benzenes can be able to be named. So in that case, I'm just going to have an illustration. So naming of a benzene molecule, of course, we talked about the numbering of the carbons on its structure, and then we can just give an illustration for that. This is carbon number 1, 2. We name the benzene structure in a sense that we give the combination of these numbers the lowest combination possible, so that the appearance of these double bonds are given the lowest numbers possible. So in this case, we're going to name this using the clockwise direction. So we have this is carbon number 3, 4, 5, 6. So these are the 6 carbons that appear in a benzene molecule. And at each specific junctions, of course, we have a hydrogen which we have not shown, of course, but we shall assume that the hydrogen atoms are attached to those specific points. There is a sigma bond for hydrogen. Individual hydrogen atoms are those specific points, except at this point that I've given it a particular substitution for the specific case. Of course, that is intentional, because we're going to use that one in illustrating what we are discussing about. So at these specific points where I have indicated the numbers, there are various or specific terms that are used for substitution at these different points on the arene molecule or the benzene molecule. So the first one is a substitution at point number 2 and number 6. That one we give it the term auto substitution. And then the substitution at point number 3, of course, let me use a different. So a substitution at point number 2 is a combination of substitution at point number 2 and 6 is referred to as auto. And then a substitution at point number 3 and 5 is referred to as meta substitution. And then the substitution at point number 4 is known as the para substitution. So in this case, all these substitution of these different points of a benzene molecule are with respect to the X substitution, which is maybe can be another molecule that is attached at this point. So we're going to use this different naming system in naming, of course, the benzene molecules which has been substituted at different points. So in this case, for monosubstituted benzenes, we're going to look at the hydrogen which has been substituted at one particular point and give it different names for the resulting molecule. So bear in mind that whenever we use the concept auto, meta, and para, they of course represent, I can give it using just this illustration. Now we can do away with the numbers since we just mentioned about them. So in this case, a substitution at this particular point with respect to X, or this point carbon point number 2 and 6. This is known as ortho. So this is ortho substitution, and then a substitution at this point number 3 and 5 is known as meta, and we're going to use those initials in naming of our compounds. And then a substitution at this point that is parallel to x, or just opposite to x, is known as para. Whenever those initials appear in our substitution, of course, especially for di-substituted benzenes, we are going to use those concepts. So suppose we have generally a molecule of benzene like this, and then we have a methyl group that is attached at this point. Then this is going to have a special name for this monosubstituted benzene that we call toluene. So whenever we mention the term toluene, it refers to a benzene molecule that has been substituted at that point using a methyl group. And in some circumstances, of course, it can be represented using Me for methyl. So that one refers to toluene. So in case we have got this molecule that we have given a resonance structure in one of our previous discussions for that video, of course, for a nitro group, a substitution of hydrogen with a nitro group at that particular point, which is a monosubstituted benzene, we give it a name aniline. So whenever we mention the term aniline, it refers to a monosubstituted benzene that has got a nitro group at that point. And then there's another one, which is a substitution of a OH group at that particular point. So it also has a special name that we call a phenol. It's an alcohol, of course, which is which contains a cyclic raffinyl group. So the name is known as a phenol. And then we can have a different molecule that has been that has substituted hydrogen at that particular point. This is a functional group for a carboxylic acid. So this is known as benzoic acid from the derivative benzene. So benzoic acid. So that's the name for that monosubstituted benzene. And then we can have another molecule still that is substituted benzene at that particular point using the OH group. This is from an acid, so it's specifically sulfuric acid. So that one is going to give a name benzene sulfonic acid. Benzene sulfonic acid. And then suppose we had a methoxyl group at this particular point. Then this one is going to be called anisole. So that's an alkoxide group that has substituted benzene at that particular point. So we shall have the name for that one as anisole. So in case we come across the name, so remember it's a substitution of an alkoxide group at that point. So in case we have an acetyl group at that point, so this one is going to be known as acetophenone. So from the combination of this name, we can see that this is for the substituent, and then for the phenyl group, that is for the benzene, and then we have on representing a ketone. So in this case, that is a ketone. From the nomenclature of organic compounds, we talked about the functional group or class of organic compound that is known as a ketone. Now suppose there's a combination of two other groups. Of course, let's give an example. We had given about a combination with an methyl, and then we said that is known as aniline. Suppose we have a methyl group that is still linked to the acetyl group that we have talked about. So we said for the first one that has got a methyl group, we said that is known as an aniline. So and then we talked about the second one that has got this kind of a group, and we said it's known as the acetophenone. So for this kind of a compound, it's known as to It's going to be known as acetanilide, catering for the aniline that we talked about and acetophenone that we had given. So this is known as acetanilide. And then suppose this, of course, benzene molecule can have a substitution of another substituent name that is known as a phenyl. Now that I said about the Robinson and Kekule structure, and I said that benzene molecule can be represented using that one. Now suppose the substituent group at this point is that molecule, then this is known as a phenyl. And if it is being attached to another benzene molecule, then we shall have it given as that. But for the sake of numbering, I said it is convenient for us to use the Kekule structure and therefore use that kind of numbering. So in this case, this kind of a compound will be known as biphenyl. So that's a substituent that is similar to the parent group that it has been attached to. So for this class of monosubstituted benzenes, of course, we're going to see how these different substituents are going to dictate the nature of a reaction of these molecules. And there are other substituent sort of groups of course, we're going to see, which have got common or specific names, just like the one that we have mentioned before. So suppose at that particular point still we have like a chloro group which has been attached, then we shall have the name for this compound as chlorobenzene. And similarly, if we have a bromo, then it will be bromobenzene, or maybe a nitro group, it will still be nitrobenzene. And then lastly, this substance is a cyano group, and it will be cyanobenzene. So for monosubstituted benzenes, we're going to locate them different names that we've mentioned. There are some of them which have a special name, unlike these ones that we can just have a look and say it's a biphenyl. We should be aware of this. Of course, it's not necessary to memorize, but it's good to understand that this is specific prefixes that are being used for different substituted benzenes, and the special names like aniline that we've come across are going to appear in some of our compounds that we're going to use, or maybe discussions that will be involving similar structures that we've drawn on the board. So in that case, this is a class of benzene derivatives, which are of course falling under the class of monosubstituted benzene. I hope this topic will assist us, of course, in understanding other structures that we may come across of a similar structure systems that we have drawn on the board. So for that case, that is it for today. Bye guys, God bless you.